So if you don't have a question, let's take a look at 8.2, which is today we're going to do the hypothesis testing for a population mean where the population standard deviation is known. So if you look at this title, you say, wait a minute, this title is just like 7.1, where we construct a confidence interval for the population mean where the standard deviation is known, which is yes, the idea is the same, which is in this case, the only thing different is we construct a hypothesis testing. So there are two methods in hypothesis testing, which is a critical value method. That's what we're going to do first. And then the p-value method. No matter which method we decide to do, the result come out to be identical or come out to be the same result. Okay, so the idea of hypothesis testing is, reminder last time we have the null hypothesis and we have the alternate hypothesis. For our book, the null hypothesis is always contained an equal sign, and the alternate hypothesis is mostly where your clamp is, right? Where your clamp, where you want to test something, where you want to find something, right? So our goal in hypothesis testing is we try to go in and we test to see how strong are we to disagree with the null hypothesis. So we want to disprove the null hypothesis. If the null hypothesis can be disproved, then we will say, well, if this thing is strong and we reject the null hypothesis, meaning our alternative, our alternate hypothesis will be what we accept or what we will use, and that will be mostly our claim. Okay, so this is what we have is the idea is we try to disprove, we try to disagreement with the null hypothesis. Okay, and again, we try to use a sample to disagree with the null hypothesis. So let's take a look at this thing here, which is what do we need to come up with this hypothesis testing or this critical value method. Well, the critical value method, which is, like I say, our goal is we want to reject the null hypothesis. And if you remember in 8.1, you only have two options, right? 8.1 lead you to two options, which is, or two results, is you either reject null hypothesis or you do not or fail to reject the null hypothesis, right? So a critical value method is this, which is the first we need to find a critical value. And this critical value, ladies and gentlemen, is the same critical value that you use in chapter 7, right? But this, in our case, this critical value will set a boundary. We'll have a boundary, and this boundary, which is depend on which kind of test you have, you will have a critical region, which is, we call that a reject region. And if it's not in a critical region, then it's in a do not reject region, which is, as you can see right here, whatever the critical value is, that's what we will use. And if we have a critical region, which is, again, this is a right tail test, which is the critical region is on the right. And this region will be my reject region. If anything fall under this region, we say it's a reject region. If it's not fall under this region, it's fall under this region here, we will be the do not reject or fail to reject region. Okay, so you have only two regions here, which is your critical value is the boundary that we will use. Okay, so how do we obtain that critical value? Well, to obtain that critical value, we have to have a significant level. And the significant level is the same as before, which is the alpha, which is for you guys, for us, for the purpose of this class, most of the time, the problem will give you the level of alpha, the significant level. And whatever that significant level is, we will use that significant level to find our critical value, or in our case, the boundary line, right? So again, the smaller the alpha, the stronger the evidence we have. So the less of the percentage we get, the better our conclusion will be, okay? As you will see in a little bit later in terms of that. So how do we obtain this item here, or how do we know if it's a left tail test, right tail test, or a two tail test, or what is our critical region on those. So just like I mentioned last time is your left tail test. If your claim is you want to test for something less than the actual value or less than the specific value, then that will be our left tail test, which is anything less than, if your inequality pointed to the left, that's your left tail test, which is left tail test, your critical region will be on the left, which is this is your reject region, and anything to the right of that Z critical value will be fail to reject. And again, as you can see, the Z-score for the left tail will be negative, and the Z-score or the Z critical value for the right tail will be positive. And again, same idea here. If it's a right tail test, any region on the right of that Z will be the reject region or a critical region, and anything to the left will be a fail to reject region. And lastly, the two-tail test, which is how do we determine if it's a two-tail test? Well, one of them is less than is a left tail, greater than is a great right tail. If it's not equal to, then that will tell you that it's a two-tail test. And if it's a two-tail test, we have two critical regions, which is one on the left and one on the right. So if anything follow under that critical region, we say that is a reject region. And if it's not follow under those regions, then we say it's a fail to reject region or a do not reject region. Okay, so again, reminder, I mentioned on 8.1, the null hypothesis, H sub 0 is a dummy hypothesis. Why is a dummy hypothesis? Because it only contains one symbol, it's the equal sign. The alternate hypothesis can take on less than, greater than, or not equal to. Okay, so either one or the other. So looking at this thing here, let's take a look at the critical value. So one thing is for us today, this is your common critical value or common level of significance, right? So significant level, which is, this is your alpha right here, which is again, if it's 0.10, 0.05, 0.01, or 0.02, that is your alpha. That is the significant level, right? So if it's a left tail, as you can see, if it's the left tail, it's a negative 1 to 1.282. If it's a right tail, it's a positive. That's the only thing different between the left tail and right tail is your critical value. One of them will be negative, the other one will be positive. So as you can see, that's your left tail and your right tail, which is looking at this reference chart. You will have this reference chart to look at. Tomorrow, I would show you in detail of how to find this critical value using our table before. Okay, so again, for today, most of our problem will refer back to this reference, table. So again, we don't, tomorrow we will do the table itself and how to find it. The two-tail, ladies and gentlemen, if you guys have questions, say, wait a minute. First of all, the two-tail, you will have two, one of them is negative, one of them is positive. For two-tail, remember, two-tail is this, right? Two-tail, we have one tail on the left and one tail on the right. So if the two-tail, you have a negative Z and a positive Z critical value. So in this case, again, as you can see, a positive, negative, meaning you have a negative Z, a positive Z. Negative, positive, as you can see, two-tail, you have two items. And if you look at this and you say, wait a minute, Mr. Tran, why is two-tail critical value for 0.10 is the same as the critical for a one-tail of this thing here where the significant is different? Well, the two-tail, reminder, the two-tail is you have two sides. And if this item, if the alpha is equal to 10, which is you have two-tail, you have to divide this by 2. And again, that's why if you divide the 0.10, which is 0.10 divided by 2, you get 0.05, which is, that's the idea, or that's the reason why we're using the same value, because the two-tail, you have to divide your alpha by 2. Okay, so again, we will mention more of that tomorrow when we have to go look for it. For now, just know that this will be our reference table for now to find a critical value. Okay, and again, the assumption for the hypothesis test, just similar to your confidence interval and your central limit theorem, which is, again, we have to have a random sample, and our sample size have to be bigger than 30. If not, the population have to be normal. It's one or the other. Those are our assumption. Same assumption from chapter 7 and same assumption for your central limit theorem. So looking at this thing here, this is the steps that you need to work on. And again, it's a long tedious step, but it's doable. It's very, very doable. So one thing is the first step, step 1, you need to state your null hypothesis and your alternate hypothesis. Meaning again, you need to have H sub 0 and H sub 1. Why do we need to state this? Because again, your H sub 1, your alternate hypothesis, tell you what kind of test you have, right? Your alternate hypothesis, if it's a left tail, we know that our Z is negative. If it's a right tail, our Z is positive. If it's two tail, we have 2Z, okay? Which is again, step 1, we need to state that, which is, we did that in 8.1. Step 2, we need to choose the significant level. But again, like I mentioned for you guys, step 2 is probably find the critical value. Find the critical value of values, because again, you don't need to choose a significant level, because most of the problem they give it to you guys. Unless you do this by yourself and construct your own hypothesis test, then you need to choose that level. But again, for us, like I say, the purpose of the class, most of the time, the level of significance will be given. Step 3, this is the one time that we need to compute, or this is the one time that we need to convert your data. Basically, we have a Z test statistic. Basically, we try to test the mean, convert the mean to become a standard normal, a Z score. So we try to find a Z-score, which is the Z-score is the X bar, which is the sample mean minus the specific value, which is again, whatever the claim is, that is your specific value divided by the standard deviation over square root of n, okay? So again, standard error, right? So step 3, we need to compute those. And step 4, this is what we want to do is, as you will see, I will ask you guys, don't worry about this thing here. You want to sketch your normal, standard normal curve. And I will mention to you guys later, which is we have 2 regions. We have a reject region, the reject H sub 0 region, and the fail to reject H sub 0 region. So we have only 2 regions. So instead of remember this thing here, I will tell you that it's a little bit easier to sketch your graph, okay? And step 5, which is the last item here, is we need to calculate, you need to state your conclusion. So again, state your conclusion. That's what we did on last Thursday. And like I mentioned to you guys on Thursday of last week, we did step 1 and we did step 5, right? Step 1 and step 5, we did those, state the hypothesis, and then state the conclusion. We haven't done the middle part, which is today. That's what we're going to do in terms of the middle part, okay? So this is the 5 step. And again, let's go down each step at a time, and then hopefully you guys can see how easy the hypothesis testing is, okay? So let's take a look at this problem. Let's take a look at this problem here. And this is what they ask you is the American Automobile Association, the AAA, right, AAA, report that the mean price of the gasoline of regular rate gasoline in the city of Los Angeles is in July 2013 were $4.04. A recent taken simple random sampler of 50 gas stations in Los Angeles have a average price of $3.99. Assume that the population standard deviation of price is 15 cents. The economist is interested in determining whether the mean price is less than $4.04 using a critical value method to perform the hypothesis testing at the alpha 0.05 level of significance. So looking at this thing here, again, this is your typical problem, as you can see. And as I keep on mentioning, the one of the obstacle in this class is how to distinguish, how to extract the information that we needed, right? How can we dissect, analyze our problem? It's all word problem and all the same. So looking at this thing here, they tell you to test the assumption, which is, again, we have more than 30, we good to go, right? We have more than 30, we have a random item, we have more than 30, we good to go. So as I keep on mentioning to you guys in this class is, list what you know, list what they give us, right? So what do we know? Well, the one thing that we know, hopefully you guys can see, the easy one thing that we know is they give us the N, right? That's how many gas stations they survey or they took out to test. They give us the N, which is 50, right? And again, what is this $3.99? Well, $3.99 is the average of this 50 gas station, which is, do you agree that the X bar with that 50 gas station, this come as average? And then they give us the population standard deviation, which is the sigma. And also they give us the alpha, right? So if you look at this thing here, beside the 2013, which is the category in terms of the years, again, we have the $4.04, the $50, the $3.99, the 15 cent, and the $4.04. And again, this one alpha, easy to recognize. So out of 5 items, we use 4 of them, we label 4 of them, we identify 4 of them, which is now what do we have in terms of the $4.04? Well, one thing is, what are we trying to test? That's what you need to ask yourself is this. What are we trying to test for this particular problem? Do you agree that this is what they want us to test is? They want us to test if the mean is less than this specific value, right? Meaning, again, the $4.04, this is your mu sub 0, which is the specific number that they want us to test, okay? And probably this is the hardest number for you to identify in your problem. Most of the time I ask my students is, look at your claim. Look at what is the economic one to claim, right? Or if you were to be this person here, what are you trying to claim? What are you trying to prove? Well, we are interested to determine if the mean price is less than the specific value. Just ask yourself, what is the specific value? The specific value is the mu sub 0, okay? So again, the mean, we're looking for the mean, which is, again, that is your mu. We try to see if whatever the mu that we're looking for is less than this specific value, okay? So, sometimes you say, this is the previous mean, right? We're trying to compare if this is the, compared to the previous population mean, okay? So looking at this thing here, this is my given, this is the item that is given to me based on the information that I can read from the problem, right? So let's go again. We haven't done the 5 step, which is the first step reminder. The first step is we need to identify or state the null hypothesis and the alternate hypothesis. So what is the null hypothesis? Well, the null hypothesis is basically tell you that the mu is equal to the specific value, right? The mu is equal to the specific value, which is the specific value is 4.04. So this is your null hypothesis. This is your H sub 0. And if this is H sub 0, remember H sub 1 can take on the less than, greater than, and not equal to. So what kind of alternate hypothesis do we have? Which is, do you agree that because they asked me for less than, because they asked me, is the mu less than the specific number, which is the mu less than? And again, because the mu is less than this number, whatever this number is, do you agree that because this thing point to the left, or the inequality is pointing to the left, we know that this is a left-hand side, left tail test, which is the left-hand side, which is our critical region will be on the left. And that's the idea of this hypothesis is, once you identify your alternate hypothesis, you should know what side is your critical value, which region, where is your critical region, okay? So again, this thing is what we did last time, which is where is the claim, what is the null hypothesis. Null hypothesis can only take on the equal side. Everything else in the alternate hypothesis. So once we have the null hypothesis and the alternate hypothesis, now we have to find a critical value. So how do we find a critical value? Well, the critical value, we have to know the level of alpha, which is the level of significance, which is in this case, we know the level of alpha, which is the alpha is equal to 0.05. They give us that, right? So look at this thing here. This is what we're looking for is, again, we know that our level is this item here. We know that our level is 0.05, which is, this is my level of alpha. And because I know it's a left-hand tail, which is my alternate hypothesis told me, right? Because it's a left-hand tail, we know that my critical value is negative 1.645, okay? And that is the important thing about your alternate. Your alternate tell you, are you using a negative value if it's the left tail test, or do we use a positive value if it's a right tail test, or if we're using both if they are both a two tail test, okay? So again, for now, just use this table to find your critical value because most of the problem will be on this common 4 item. Tomorrow we will do something that is uncommon, okay? So looking at this thing here, we have this critical value. Now I ask you this question here for step 2, sketch your normal curve. Sketch your normal curve, which is, again, reminder, this is your normal curve, your symmetric bell-shaped curve, which is, again, your small mountain, your perfect mountain, right? And then we know that this is our critical value, basically tell you where is the critical value because it's the left tail test. I have this line, doesn't matter where, just draw a line. And because it's a left tail test, shaded the item on the left, because again, this is your reject region on the left and your fail to reject region on the right. And that is your critical value or critical region. The critical region is the reject region. So now, this is what we have is we sketch this item here. We have a boundary and our boundary is our critical value, which is now anything to the left of this critical value because it's a left tail test, it's a reject region. Anything to the right is a fail to reject region. You have only 2 regions. So how do we know if it's a reject or fail to reject? Well, step 3 come in. We have to compute the Z score. We have to compute this Z test statistic, which is, again, the Z test statistic just basically tell you to plug in the X bar minus the mu sub 0 all over standard deviation divided by square root of n, which is, do you agree that we have those 4 items? We have the X bar, we have the mu sub 0, we have the n, we have a standard deviation. We extracted from the previous information, which is if you plug it in, I have 3.99 minus 404 divided by 0.15 divided by square root of 50. So if you divide this, or if you take the 3.99 subtract the 404, you will get negative 0.05. And if you take 0.15 divided by square root of 50, you will get 0.0212132034. And again, if you divide this thing here, if you take negative 0.05 divided by 0.021, you will get a negative 2.35. which is, that is your Z. That is what you convert your data to become a standard normal, okay? And one thing is, if you were to type this as a whole thing on your calculator, make sure you put the parenthesis on the numerator and the parenthesis on the denominator so that your calculator can calculate the numerator first, calculate the denominator first, and then divide the 2. If you type sometime, if you don't have a parenthesis, they would say that you tell them to take 4.04 divided by 15 first, because remember, division or operation, right? Division is over subtraction. So the calculator may divide before they add or subtract, okay? But again, go back to this problem. This is what our Z. So step 4, this is what we do is, step 4 tell us this. We know there's a reject region and a fail to reject region. We know that we have those 2 regions, and we know our boundary is negative 1.645. Now our Z is this, which is our Z is negative 2.35. 5702, do you agree that the negative 2.3 is less than negative 1.6, which is something on the left side of negative 1.6? Doesn't matter where, it doesn't have to be exact. We know that this number, the bigger the negative, the smaller the value, right? So the bigger the negative, the more debt we're in. So negative 2.3 is less than negative 1.6, which is somewhere here. Which is, do you agree that this thing here is fall under what kind of region we have? Which is this thing fall under the reject region. And if it's under reject region, we will reject the H sub 0. So that's your result in step 4. Before you can do step 4, you need to know step 2 and step 3, right? We need to know the boundary, we need to know the region, and then we need to know where our actual data, our Z, fall under. And once we have this, and if you want to look at the other one, the one that I told you guys to disregard is if the Z is less than the critical value. If it's less than equal to the critical value, then we reject, right? So we reject if negative, which is in this case, this is true, negative 2.35 is less than negative 1.6, which is, again, because it's true, we reject, which is this follow the same result regardless of what you do, right? And again, step 5, everything, the 4th step come to this conclusion, which is step 5. You have to state the conclusion. And if you remember on Thursday, I told you guys that you have only 2 options. You either reject the H sub 0 or you do not reject the H sub 0. And if you happen, in this case, reject H sub 0, then the conclusion is you have enough evidence to support whatever you try to support, whatever the test is. If you fail to reject, you just say you don't have enough evidence to support whatever the claim is. In this case, I see that we have enough evidence to conclude that the mean price of a gallon of a regular gasoline in Los Angeles is less than $4.04, because that's what the economic try to claim, right? Try to prove. So the claim is in, again, like I mentioned, on Thursday, if we have only 2 options, right? Which is, we go back to step 1, we have this option here, which is we either reject, and to go back, you reject H sub 1, H sub 0, which is, again, if we reject H sub 0, meaning we throw this thing away. And if we throw this thing away, then we have only one hypothesis left, which is this is what happened where to be my claim is at. That's what I want to claim. I want to claim this thing here. So if I throw this thing away, meaning, again, I have enough evidence to support the claim that I try to make, right? So that's the idea here, is you either reject, meaning throw this thing away, or fail to reject, meaning you cannot throw it away. And when you cannot throw it away, you have 2 hypotheses. You don't know which one will work. You just go back to square one, and then you just say, I don't have enough evidence to support for now. I don't have enough evidence, okay? So again, question with the 5 step. Again, step 1, state the hypothesis, find the critical value, find your region, compute the test, and then see where your item fall is under the reject, we reject. If it's under fail to reject, we fail to reject. And again, if you reject, which is in this case, you reject the H sub 0, you have enough evidence to support whatever the claim is. In this case, the gasoline is less than $4.04. Question with the 5 step we have here. All right, let's try another one. Let's try another one, and then we see where to go from there. Again, same thing go with this example 2. They ask you, are you smarter than a 2nd grader? Title of the question. A random sample of 60 second grader in a certain school district are give a standardized math skill test. The sample mean score is 52. Assume that the standard deviation of the test score is sigma equal to 15. The nationwide average score on this test is 50. The school superintendent want to know whether the 2nd grade in her school district have a greater math skew than the national average. So again, where is your claim, or what are you trying to claim? Hopefully you guys see that this is what she wants to claim, right? She wants to claim if her school district have a greater math skill than the national average. Okay, so that's what we want to prove. We want to prove, does the data show that her district have a greater skill than the national average? Okay, so looking at this thing here, before we go further, right? Before we go further, this is what I want you to practice the habit of. If any word problem, any math word problem, practice the habit of identify what they give us. And in this case, hopefully you guys see that they give us everything we needed, which is, again, do you agree that they give us the n, right? That's easy to spot, which is how many sample? 60. That's our sample. They give us x bar. Well, they identify the x bar for us, which is x bar equal to 52. And they give us the population standard deviation. Again, they don't say population standard deviation here, but they give us the sigma, so we know that it's population standard deviation. Remember, how do we identify, which is last time I just say with the standard deviation, then that's mostly a sample. But this case, they give us a sigma, which is that's your population standard deviation. So probably you could say, well, the only number left is 50. So what is this 50? Well, this 50 is the national average. And that's what she wants to claim, right? She wants to claim if her grade or her school district have a greater skill math level average than this specific number, which is the specific number is 50, right? So again, looking at this thing here, everybody see where my full number came from. My specific number is the number that we want to compare with. We want to make a claim, make a statement with. Okay, so again, this one here, they didn't ask you to do the 5-step, but again, you pretty need to do the 5-step to answer A, B, and C, right? So A, they ask you to state the null and the alternative hypothesis. So reminder, what is the null hypothesis? The null hypothesis is the mu is equal to a specific number, which is in this case, the specific number is mu sub 0, which is equal to 50. And now, what kind of test do we have here, which is hopefully you guys can distinguish that greater than. She wants to test, does her school have a greater than average than the national average, which is, again, this is the mu is her average, her population, her school population greater than 50, which is the specific number. So whatever the specific number, that's the same specific number we're using. And again, we know that this is a right tail test because the inequality point to the right. That's what we need to know from the hypothesis test we have here. So this is a right tail test, which is everything point to the point to the right is right tail test. But again, let's take a look at, we're done with A, right? A just asks you to identify H sub 0 and H sub 1. We got that. I just give an extra piece for you guys to identify if it's the left tail or right tail or two tail. So now, part B, they ask you to compute the value for the test statistic. So the test statistic we have is basically they skip the step 2, they jump to skip step 3, which is reminder, the test statistic is this, which is the Z equal to the X bar minus the mu sub 0 divided by standard deviation all over square root of n. Which is, again, if you look at the given item, we have the 4 items that we needed to find this Z, which is the 4 items we needed, which is the 52 minus the 50 divided by 15 divided by square root of 60, which is, again, I have 2 divided by 1.93649. And again, if I take 2 divided by that, I would get 1.0327. Right. So looking at this thing here, that's what I have, which is, again, they asked me to compute. I got it. This is my Z. Now they ask you to state the conclusion. Well, in order for you to state the conclusion, you need to know what the result is, right? Which is, again, looking at this thing here, we know that they give us the level of alpha is equal to 0.01, which is, again, to know if we support the claim or we don't have enough evidence, we have to know where the Z fall under. Is it fall under the reject region or the fail to reject region? So in order to know that, well, let's sketch it out, right? This is my boundary. Doesn't matter where you put the line. This is your boundary. And with this boundary, we know that this is the fail to reject region, and this is the reject region since it's a right tail test. And now, what is this boundary? Well, if you go back to this table here, they ask us 0.01 as your level of alpha, and the right tail test tell us that it's positive 2.326. Everybody see that 2.326 will be my critical value, which is that is my boundary 2.326. Now, is 1.03, your test statistic is 1.03 on the left side of 2.3 on the right side of 2.3. And hopefully you guys say that is on the left side, which is again, 1.03 is smaller than 2.3, which is any smaller number will be on the left of that number, which is this is where 1.3 fall under. So if you can see this thing here, which is again, is under the fail to reject or the do not reject region, right? If it's on the left right here, it's under the fail to reject. And like I say, ladies and gentlemen, if you fail to reject, then your conclusion, this is your conclusion. Your result tell you the conclusion is at this level of significance, we do not have information. We do not have enough data or enough evidence that the mean grade of the school superintendent district is greater than the nationwide average. Okay, so again, like I mentioned to you guys, you have only two options. If you reject, you have enough evidence to support whatever you try to support. If you fail to reject, then you say you don't have enough evidence. That's all. Okay. So again, let me ask you guys a question with this part A, B, or C here in terms of how to find this, how to identify the hypothesis and how to come up with the conclusion. I'm sorry. So everybody good with this critical value here? All right. So the critical value is just like the name. We need to find a critical value, which is the boundary, and that critical value based on your level of significance. Now let's take a look. Let's take a look at another method. So another method, we try to do this hypothesis test, and we call this a p-value method. So the p-value method is basically you try to find a probability that h sub 0 does not occur. Okay, so this is our goal, is we try to find a probability that h sub 0 cannot occur, meaning if you select the item and that item does not belong on the h sub 0 hypothesis, right? The null hypothesis. So this is what we have is basically the smaller the p-value. We try to calculate this p-value. The smaller the p-value, the stronger the evidence against the h sub 0. Meaning the bigger the p-value, the less the least that evidence we have, right? So the smaller the p-value, meaning the smaller p-value just basically tell you that the smaller the probability that h doesn't occur, h sub 0 doesn't occur. Okay, so now how do we know, how do we find this p-value? I will mention what the p-value is and kind of how to, what we do to find it. Later on, you will see that you probably won't do this much. But again, let's take a look at this idea of p-value. So go back to our previous problem. Are you smaller than the second grader? So to find the p-value, the first thing we need to do is we need to find our z, which is our test statistic. So again, the same test statistic we did in step 3 in our critical value item, which is again, is the same formula as we do in chapter 7.1, which is this is our z test statistic. So once we have this thing here, this is what we need to do is to find a p-value. Basically, we need to find the area underneath the curve. Okay, To find a p-value is basically, again, how do we find the probability in chapter 6? We find the area underneath the curve. How do we find the area? Which is, if you recall, to find the area, we need to use that normal CDF, right? We have the Z, we have a Z, and we're looking for the area to the right of that Z score, which is, how did I get the Z score? Well, I put in this formula, this statistic test that we have, right? This statistic test that we have, which is, again, I plug in, I have my Z. And now I just need to find the area, because the area underneath this curve is the same as the probability, which is, in this case, is the same as the p-value. So again, p-value is the probability, which is, that's what we're looking for, the probability against h sub 0. Okay, the smaller, the better, I should say. So looking at this thing here, if you remember your normal CDF, we have normal CDF, which is, again, my lower limit is 1.03. My upper limit will be some humongous number. My mean is 0. My standard deviation is 1. If I plug it in, you will see that it's 15%, 0.1508, which is, that is your p-value, ladies and gentlemen. So again, how do you make a decision now, right? You say, okay, I can find the p-value, which is, the p-value is area under the needed curve. And if I have a Z, I can find the area. But now, how do you make a decision? Do you reject or do you not reject, right? So this is how you make a decision based on your p-value. So this is the p-value, this is the area, this is the percent, or not the percent, the probability I just found, right? So remember, the smaller the p-value, the stronger the evidence. So basically, this is what you compare to, is if the p-value is less than the alpha, then you reject the H naught. If the p-value is greater than the alpha, then we say we do not reject H sub 0, which is, again, that's what we do here is, if we recall, if you got recall, my level of alpha is 0.01, right? My alpha, based on our, are you smaller than the second grader problem, our alpha is 0.01. And the p that I found, the p-value that I found is 0.15, which is 0.15 is greater than 0.01. And because p is greater than alpha, I do not reject H sub 0, which is, again, H sub 0, which is follow or is the same conclusion as we had before. Remember, your critical value, the critical value is, our item is fall on the right-hand side, or on the left-hand side of the critical value. Therefore, we fail to reject. The p-value method is, because of the percentage, or the probability is greater than the alpha. Because it's greater than alpha, we do not reject, which is, they lead us to the same result. And then from the result, we can state the conclusion, which is, we don't have enough evidence to support the information. Okay, so the idea of this piece question with this p-value, or the idea behind the p-value, just know is, if p is bigger than alpha, we do not reject. If p is smaller than alpha, we reject. Okay, so again, this one here is less than or equal to. So rarely you will see equal to. Rarely the p-value is exactly at the level of significant, the alpha. So, but again, if it's equal to, we reject to. So less than equal to, we reject. Greater than, we do not reject. Okay. So let's take a look at this thing here, which is, again, this, ladies and gentlemen, like chapter 7, your calculator can help you out a lot. Meaning your calculator can make, they cannot make a decision for you, but they can do the calculation for you, right? So again, step 1 and step 5, you have to do it. You have to state the hypothesis. You have to identify if it's a left tail or right tail or a two-tail test. And then, look at your output, you do your input and look at your output, then you can make a decision or make a conclusion based on your output. So look at this thing here. How do we utilize this calculator? Well, to utilize this calculator, which is, again, is the same as your interval, which is if you hit stat and you go over to test, the first choice you will see is your z-test. And right underneath, just like you expected, right underneath is the t-test, and that's what we're going to do tomorrow. But for now, the z-test, right? So again, if you select the z-test, make sure that in the input, your stat is blinking or select, right? Make sure that you choose stat and not data. And from there, you basically just fill in your data. So if you look at this thing here, if you look at our data, again, this is what we have is we have the n, we have the x, we have a sigma, we have the mu sub 0. We know it's a right-tail test because of our hypothesis, the A sub 1. So if you look at this calculator, here, which is, if you look at this calculator, which is, again, you just hit stat and you go to test. And then again, like I say, the first option, your z-test. Last time in chapter 7, we used the z interval. This time we use the z-test. And as you can see, t-test, which what we're going to do tomorrow. And the one prop z-test, which is number 5. That's what we're going to do tomorrow too. But again, for now, we use the z-test, which is, this is what you should get. This is what you guys should see on your screen. 83 and 84 is the same, which is, again, make sure your stat is blinking or selected. You go to your x sub 0, mu sub 0, which is what is your specific number. The specific number is 50. And what is your sigma? Your sigma here is 15. What is your x bar, which is 52? And how many sample do you have, which is, again, 60, right? And again, make sure that everybody make sure that this is a two-tailed test, which is not equal to, that's the two-tailed test. Pointed to the left, that is left tail, and pointed to the right. Everybody see that you go over to the far right, which is, this is a right-tailed test. Don't worry about the symbol here. Just worry that if it's the inequality pointed to the right, that's the right-tailed test. The inequality pointed to the left, that's the left-tailed test. And the inequality is not equal to, that's the two-tailed. And then you just go in and click calculate. And voila, ladies and gentlemen, your calculators do some wonder, right? Which is, again, we did the formula in the critical value, we did the z, which is the z is 1.03. In the p-value, we did the p-value, we do the normal CDF, and we got this, which is, ladies and gentlemen, this is your output. You have two items here, which is the z is your z test statistic, and the p is your p-value. So again, look at this thing here. You can see that the p-value is bigger than our level of alpha. We do not reject. The p-value is bigger, we do not reject. The p-value is smaller than we reject, right? So looking at this thing here, this is what we have, which is, as you can see, everybody have this thing here on your calculator. And hopefully you guys can see that there's only two items, which is, again, well, three items. We know it's a right-tail test. Make sure it's a right-tail test. We know this is your z and this is your p-value. So question on how to use your calculator, which is now, once you know how to use your calculator, out of the 5 steps, you only need to do step 1 and probably sketch so that you can see where your critical value. If not, look at your p-value and then do your step 5. You have to state the null hypothesis and the alternate hypothesis, and then you have to state a conclusion. You have to know what you do. But again, let's take a look at this example. If you don't have question with this screen right here, let's take a look at this example. And again, like I mentioned to you guys, the hardest part of this class, right? The hardest part of this class is extract out the information that they're given to us. If you can do that, then this problem will be easy, right? So heavy children, Or again, that's the name of the title. Are children heavier now than they were in the past? The National Health Examination and Nutrition Survey, published in 2004, reported that the mean weight of a 6-year-old girl in the United States was 49.3 pounds. Another survey published in 2012 reported that a sample of 177 6-year-old girls have an average weight of 51 pounds. Assume that the population standard deviation is 17 pounds. Can you conclude that the mean weight of the 6-year-old girl is higher in the year 2012 than to the year 2014? Use the alpha level of 0.01. So looking at this thing here, again, like I mentioned, first of all, you have to identify what information they give us, right? So do you agree that they give us many things, which is they give us the N. We know that they give us the N, which is 177. That's easy, right? How many sample we have? 177. They give us the X bar, right? How do we know the X bar? Because with this 177, the average mean of just this 177 girl is 51.9. And also they give us a standard deviation and they give us the alpha, right? They give us the alpha level, which is alpha is that. So now the only thing left is the 49.3, which is, do you agree that is your specific number that you want to test, right? You want to test. What do you want to test? Well, you don't know if the weight is higher or lower. You would say, well, Mr. Tran, the number look higher, but again, the number can be deceiving, right? Looking at this thing here, this is what we want to claim. We want to see if the weight in the years 2012 higher than the years 2004, right? So again, looking at this thing here, which is what is the years of 2004, that is your specific value. That is the number that you want to compare to, right? You say, well, obviously 51 is higher than 49, but again, this 51 is only based on this 177. This 49 based on the whole population of the 6-year-old girl, so we cannot compare. That's not apple to apple. We cannot take the sample and compare to the population, right? And that's why we have to do all the testing, okay? So looking at this thing here, everybody agree that this is the information they give us, the 5 items we needed. And if we have this 4 items, we don't need the alpha, right? We don't need the alpha. The alpha there is for us to make a decision, but we don't need the alpha to calculate. Because if you remember, if you use your calculator, right? But before you use your calculator, this is what I want you to do is you need to identify your hypothesis. You need to identify your H sub 0 and H sub 1 so that you know what kind of test you have. So looking at this thing here, like always, the H sub 0 can only be equal to. The H sub 0 cannot contain any other symbol except the equal to. So again, mu is equal to the mu sub 0, which is the specific number, which is 49.3. And if this thing here, what is the mean? Greater than. Do you agree that we want to see if the mean is greater than this number? Whatever this number is, we want to see if the average is higher than this number here, which is, again, whatever number that you have in here is the same number you have in here, which is, again, mu is greater than. And if it's greater than, do you agree that this is a right tail test? Again, it's pointed to the right, it's a right tail test. So looking at this thing here, if you have this, which is we know is a right tail test, all you need to do is you go to your calculator and again, identify this item here after you can calculate your calculator. But again, looking at this thing here, this is my right tail test, which is again, my reject region on the right, my fail to reject on the left. I sketch this thing here. And again, hopefully you remember. If you don't, reminder 0.01, right tail is 2.326. So again, that is my boundary. That is my cutoff. That is my line. So if it's 2.4, it's on the right, that reject. If it's less than 2.3, it's on the left, and I fail to reject. I do not reject. Okay. So looking at this thing here, and again, like I mentioned now, you have to do this by yourself, which is identify the hypothesis so that you know if it's a right tail, left tail, or two tail, and sketch your normal curve. Find a critical value, find a cutoff line, right? Because now if you use your calculator, if you plug in the stat, the test, the z test, you should have the z equal to 2.03 and the p-value is 0.02. Okay, so if you plug into this thing here, which is where is 2.03? Well, 2.03 is somewhere to the left of this 2.3 because 2.03 is smaller than 2.3, which is if it's on the left, everybody see that if it's on the left, it's on the fail to reject region. Or if you don't see that, you can see that the other way is, do you agree that the p-value is bigger than the alpha? The p-value is bigger than alpha, we still do not reject. And if we do not reject, basically this is what we say, we do not have enough information, we do not have enough evidence that the mean weight of a 6-year-old girl is higher in the years 2012 than of that 2004. Okay, so you look at this thing, yes, obviously the weight is higher, but again, this thing is based on the sample and this thing is the population. So we cannot just use the sample and compare to the population. We cannot just say, oh, it's higher, so therefore it's higher. We cannot do that. We have to do more statistic tests, okay? So again, look at this thing here. First of all, question on, anybody do not see the Z and the p-value on your calculator? So everybody got this Z and this P value on your calculator after you type in your Z test and the right tail. Make sure it's the right tail, not the left tail. Okay. So now question on how can we use in this? How can we use in this? Which is again, that's why, you know, tomorrow, as you will see, tomorrow we do the same process, same procedure. The only thing different is instead of a Z test, we do the t-test, which is again, your z-test or your t-test, your calculator can calculate for you. It's you who have to make the decision. Do you reject the null hypothesis, which is in this case, we fail to reject. We cannot throw this away. And if we cannot throw this away, you don't know which hypothesis is true. We don't know, so we just say we don't have information now. Maybe I go in and collect more data. Maybe if I have, instead of 177, maybe if I have 300, then I can tell you we can reject, right? But for now, based on this information you give me, I don't have enough evidence to support that the weight of the girl in 2012 is heavier than the girl in 2004, okay? So again, look at this thing here. Question on what we need or what you guys need to do to compute this hypothesis testing. Any question on how I come up with the conclusion or the calculator value? Well, if you don't have question, ladies and gentlemen, this is the end of 8.2. As I mentioned to you guys, 8.3 and 8.4 is the same as 8.2, which is the process is the same. We have to state the hypothesis. We have to sketch our normal distribution, our bell-shaped curve to know where is my reject region and where my do not reject region. And then we have to calculate, which is now we can use the calculator because it's shorter, faster for you to calculate the Z and the p-value. And then again, you have to base on the p-value or the Z and come up with your conclusion. Either or, but both answers should be the same. If you say, oh, if the p-value is always there, I don't need to find a Z. The reason is your homework specifically asks you to find a Z. So if they ask you specifically find a Z, you have to tell them what is the Z test is, which is this Z right there. Okay. If they ask you for the p-value, you give them the p-value. But again, the idea of the p-value, no, not many people remember it. all they remember, or one thing that they remember is that the p-value, if the p-value, which is the probability that H does not occur, right? If the p-value against H is bigger than the alpha, we do not reject. If the p-value is smaller than the alpha, we reject H sub 0. Okay, so again, that's the only key thing that I want you to remember for p. Well, you can remember the other one, but p-value bigger than alpha, we do not reject. P-value smaller than alpha, we reject the H sub 0. Okay. All right. Any question here? All right, ladies and gentlemen, if you don't have question, let's call it a day for today. We will continue with some of this 8.2 tomorrow, and then we will start 8.3 and probably end up with 8.4 tomorrow. So again, as you will see, tomorrow is the same drill, it's the same process. No more introduction on how to do it. We just go in and do it, okay? So again, if you have question, please stay back. If you don't have question, be safe out there, guys. I will see you tomorrow. Same time, same place. Have a good one.